So in this video we are going to solve a problem of CSIR NET December 2018 paper. This is a question of quantum mechanics. It says that a system of spin half particles is prepared to be in the eigenstate of sigma z with eigenvalue of +1. And now it says that the system is rotated by an angle of 60 degrees about the x-axis. After the rotation, the fraction of the particles that will be measured to be in the eigenstate of sigma z with eigenvalue +1 is what? So you're having a system uh, already prepared to be in the eigenstate of sigma z with eigenvalue +1, but now the system has to be rotated. So then in the rotated frame, so you can say in the rotated system, and the eigenstate of sigma z with eigenvalue +1 will look something like e to the power minus I sigma x theta by 2 operating on psi, where psi is the eigenstate of sigma z with +1 eigenvalue. This e to the power minus I sigma x theta by 2 is actually the rotation operator, which rotates a ket vector about the x-axis by an angle theta. So the probability of the particles to be found in the eigenstate of sigma z with eigenvalue +1 will actually be given by the mod squared of psi with psi, both psi in the new state, and there you have to sandwich sigma z in between, because you have to find the eigenstate of sigma z. Okay, so what we really need to find out is the quantity in between the two sides. What is that? So if you look at carefully, it is actually a combination which looks like e to the power some operator a into b into e to the power minus the same operator a, which is the form we see in the Baker-Campbell-Hausdorff formula, and therefore it can be simplified using that formula, and you can write this operator as sigma z plus the commutator of sigma x with sigma z times I theta by 2 plus 1 by 2 factorial times I theta by 2 the whole square, and the commutator of sigma x with the commutator of sigma x and sigma z, and so on. This will be a series, and you can simplify this series if you know the commutator relations between the Pauli matrices, which you can which you already might be knowing, that sigma x with sigma z will give you minus I times the sigma y, and thereby you can simplify this expression, and after writing the sigma z operators together and separated from the sigma y operators, this actually simplifies, this full operator actually simplifies to sigma z into cos theta by 2 plus sigma y into sin theta by 2, and therefore for a rotation by 60 degrees, this operator actually becomes root 3 by 2 times sigma z plus half times sigma y, and therefore you find that the probability of finding the system in the eigenstate of sigma z and with the eigenvalue +1 in the rotated system is given by the mod square of root 3 by 2 the whole squared, mod square of root 3 by 2, which is equal to 3 by 4. Okay, so the correct answer is the option 4. Okay, so thank you for watching the video.